This is about hull survey, and that is in this case in classification. Our objectives are find class requirement for ships regarding hull, and find requirements for preparation for survey. It's stated here. It's not that stated in SOLAS, but here it's stated how to prepare for a survey, and we're going to think for ourselves a little here about how to prepare for a certain survey. And it's regarding classification here, and classification is that we have components that have their own approval, and we check the class, the standard, if the standard is still fulfilled. So something we can measure here, performance of some components here. We're going to talk about survey extent. We're going to use the material from DNVGL Part 7, Chapter 1. This is the document that is all about ships in service. That is survey requirements, I'm sorry. Survey requirements, all about main class, not statutory. So statutory, that is the legal thing, that is regulations. Here we have rules in this case. So the regulation in SOLAS, one regulation in SOLAS says that we have to fulfill rules of a recognized classification society. So some concepts we want to use here is external survey, hull deformation, bottom survey, other damages. And we're going to mention also thickness measurement a little more, UTM, ultrasound thickness measuring, UTM teams of 2 persons usually. We're going to talk about CAP, Condition Assessment Program, which is a voluntary program for assess hull, the condition of hull, and also for some class societies is also regarding machinery. And close-up survey, as it is required by surveyor and in regulations here. That is, if you will look a little extra in certain areas of the hull structure at the welding connections and such, where it is more probable with damages like cracks. So first of all, what is required to obtain a certificate of class? It's required to have fulfilled the main class. And we're going to talk about main class, and the text in hull in red here is hull. That is for today's lecture. Next time it's about machinery. We will also mention miscellaneous items like rudder, shaft, boiler, that's included in main class. It's got its own chapter here. Now, hull survey and a little about miscellaneous items as well. And the certificate of class, main class, hull survey. We're going to talk about this class rule structure. This is a PDF file. You have it in this module in Canvas. So you can open it, and you can follow also in the margin on the left side. You can have these plus signs like we saw them in this Lloyd's rule finder, the same kind of function here. And thickness measurement, as I said before, a close-up survey, preparation for survey, alternative survey arrangement. We have also continuous class in PMS, and this condition assessment program, the CAP class. We have CAP class in 3 grades here, CAP 1, CAP 2, CAP 3. And CAP 1 is the best one. And if you have CAP 1 as a tanker, you get a better charter, more money, that is. First of all, this document, the DNV Part 7, Chapter 1, how it looks like with all these plus signs like this. Don't drown, don't look at the right side here. But I can just say that on the right side, we have these plus signs expanded. First of all, we see this section 1, general, always apply. You check this, you click the plus here and see, does this really concern me? Do I have to think about this or not? You should just scan this and see what is required from you in that case. And we're going to focus on renewal survey. So that means, as we see here, the next one is section 4, renewal surveys, extent, main class. And the section 5 does miscellaneous items like boiler and rudder and such. And also the bottom survey is mentioned in section 5. And what you do here, if you just, how are you going to find your requirement that you're interested in for the moment? You just see here, the section 2, let's see now, annual surveys. But that is not what Mats said. He said renewal, right? So we just passed that one. Section 3, intermediate. No, that's not it. So you go to section 4, and you do the same thing there. Click the plus sign. What is this about in this case? And if it's about hull survey, you can see later. We're going to go to that section and focus on that one. So these are the subsections here. You see to the right side, it is the right column here is 2.1 general all ships. That is about all the survey items you're going to check on the hull. And also this focus is under 2.4 oil and chemical tankers. And we're going to talk about oil tankers. And from that part of this section 4, we find also tables of close-up examination and thickness. We're going to talk more about that. We have a little exercise together where we're going to check what is required from us. And what we're going to learn about this is that you should just try not to drown in all these pluses and all these subsections. You just go to what this is about, what you're about to do, and just close your eyes about the rest and forget about it for long. So much. Click and see what's relevant and see. So again, relevant for main class. One more time, both machinery and hull. First general, click it to see what's inside, that one. And then you have also access. I mean, you're supposed to provide access if you work on a ship for a class surveyor so he can climb into the tanks, and you should make it clean enough so he can see the surfaces for corrosion and such. And also you should prepare with the machinery and system so it's clean enough for him to check. So if you know what you're expecting, it would make the survey much better. And down here in this section 4 is how to examine the document review. Documents you're going to check here, or a document that is the class surveyor is going to check. I'm sorry. And of course, it's good if you know what those documents will be so you can prepare them and put them on the table before he's there. And the survey activities, hull equipment, machinery and systems. And the close-up surveys and UTM, the thickness measurement, as it was referred to before in the previous slide. And survey methods, PMS or continuous survey. Here they are. So this tree structure, if I would describe it in like a Christmas tree here, would be very complicated. So I think it's actually easier if we just use this tree in the class survey requirement like this with the plus signs. And the procedure is quite easy to reach if you just know what doesn't concern you for this for the moment. So, but I'm going to describe to you and tell you what those parts of this document is about and what we can expect to find inside. So if you look for something, how should I prepare? Then you will recognize it and say, I will look in this place here. So we go for general requirements and we see. We go for the oil tanker and renewal survey, like I said. In this view, I have the yellow block supply first. And the survey requirements, this part 7, chapter 1. And what is relevant to us right now, it's not the annual and the intermediate surveys, it's the general requirements. Not so very much. Mostly in section 4 we have for this. When we start with this general requirement, it's about axis and stuff, like I said. So I'm going to change this tree so we go down one level, and below this journal we have the definitions. What is the survey, what is access, what is ventilation, what's required from us here, and periodical surveys, which periods, surveys of special equipment and systems, and postponements of periodical surveys. If we're in the middle of the ocean, I cannot make it to port in time for the survey. How to postpone. It's described in a quite short chapter here, actually, short paragraph even. And also we see 1.5 surveys of ships out of commission. Okay, your ship is laid up for 2 years maybe, and you don't want to lose the class because that is a disaster. So you have to do something to keep it, to have it, the ship to stay in class, but with very, very little surveys then. How to make the ship get real service certificates again. Well, you check this chapter, this paragraph here. And 1.6 survey schedules. The next view I'm going to go over to this PDF view again, like this. So first of all, you could just scan this one. It's just half a page something. Does this concern me? Probably not. The next one you go to regarding the hull, general all ships, those are the survey activities, what you're supposed to do. I'm going to check ballast tank port side number 6 something. And you're going to check the windlass, you're going to check rudder and rudder something else. But you're going to check all these small items. We have a list maybe 50 items here for the hull. The machinery list is about 150 items maybe. So we have an oil tanker. That means we can just skip the 2.2 and 2.3, and we go to 2.4. Oil and chemical tankers subject to enhanced survey program. That's our ship, above 500 gross tons. So these are first survey activities, all ships, and the ship-specific survey activities for oil and chemical tankers. Then again, this rule structure, this complicated one. I don't want you to be scared about these views here, but I just want you to know what's inside these regulations and that it is there. If you just click away and you learn not to click the wrong plus sign, of course, because then you're drowning in all this. So conditions for survey and access to structures. Under hull and equipment here, we have cleanliness, removal of scales and loose rust, accessibility, safe access, gas freeing, illumination. You're supposed to arrange illumination in those tanks that are going to be surveyed. And then we have also the next view here is about this. The big one here, section 4, renewal survey extent main class with a ship type specific items to check. And then we have go to this one and we see this. Also we have below this one, we have oil and chemical tankers 2.4 and all this 241. You recognize this view from this PDF document also. You saw the same thing, 242 for instance, and requirements for thickness measurement. That refers to that other section that we talked about before. On the left side, 2.1, under that one, you see first 211, right? That's miscellaneous survey activities. That's for all ships. And 212 is bottom survey. 213 suspect areas follow-up, small part of this, but the other one, 6 pages of instruction about how to do these surveys, how to check the windlass, how to check this the tank, how to check whatever it may be. So journal checking, documentation, verified draft marks, etc. here first, and then this one here refers to miscellaneous main class items. It should be actually pointing at 211 here, so I don't know what's happening with this. And the tables referred to from hull and machinery are those about close-up examinations, thickness measurement. We're going to have an exercise about this, as I said, and the machinery survey methods as well. And let's see now what to do. 211, what to do. We check the windlass, for instance, and how to do it is below that one. We're going to see those little parts of this PDF. It's not so scary. You just have to follow the references. That's all. That's actually all. And don't drown in these descriptions and stuff. Just check and click on this description, and you're going to know how to do it. But there is a little left for your imagination as well, and your experience in how to check stuff. We're going to have an example about that too. So We have subsection 211 to 214, what to do, and again, ship type specific. For instance, subsection 424 for oil tankers, what to do, referring to how to do it. So in the windlass example here, how to examine the anchoring equipment. So we can find the scope of the survey, looks like this here. 211B, anchoring equipment, C215. So check the anchor equipment, is it there? We have an anchor equipment. So what we're gonna do here, we will click on this one, 215. If we click on this, we will go directly to the description about how to do it. So we check 215. It is that easy. It's this text, windlass including piping system and foundation shall be examined. Okay, the anchors and chain cables shall be ranged, examined, and then required complement and condition verified. Okay, we have a description here. Like I said, see here also, 12% of its initial diameter, that's a requirement. So if it's 100 millimeter thick, something, it could be 88 millimeters after. Then we lost 12%. Of course, this anchor chain, that would be incredible. So it's just to make it easy to understand here. And examined. First, how to examine. We have a few tips here about how to examine. So we check foundation. That is from our own experience and knowledge about cracks and the forces acting on this equipment. Check foundation for cracks, deformation, and corrosion. And I think we check the anchor and chain for damages. Lay the chain in loops or as it should be arranged in the second row of this paragraph above here. Lay the chain in loops in dock. That's usually what to do. You put them like 10, 20 meters back and forth like that, and you check them if it looks good or not. And you take some samples. You check the width, and then you check the height of the cross section, and you just estimate the difference. Then you examine the chain boxes, the chain locks, drainage from the chain box as well. And after the first inspection, measure the cross section, like I said, of links, 12% de-rusting. So measure at least 3 links, it says up here also, per chain length is 15 fathoms. It's about 28 meters, 1 shackle, it's also called. So these are my own little instructions that would be suitable, I think, as an example for this windlass checking, also based on the text in the 215. About the scope of survey hull and how to survey. It's in this 211 I mentioned before, and that is referring to, just like for the windlass, the part B in 211. Windlass, check 215. So we can do the same thing about how to perform the activities above. We go to we click on the link that moves us forward in the document with the description. And we have also additional scope here for a tanker. We're going to find out what to survey on an oil tanker at the renewal survey. Yellow box here, reply. We have the general requirements again, and activities under section 5 as well. In addition to this, the boiler bottom survey, shaft survey, 211, description about this clean spots of soft and semi-hard coating removed. Soft coating, I don't think you can find it on any ship anymore. But we have semi-hard and hard coating, epoxy. So that is how to prepare for survey in a ballast tank, for instance. And if it's in the superstructure, the accommodation, ceilings, linings to be removed as instructed by surveyor, it's not very common they do that. Check linings and in the accommodation and take away all this stuff, insulation to check it. And also regarding ventilation, illumination in these compartments like the ballast tanks and the means of access. You should plan for some kind of access to the structure that's quite hard to reach for survey. Under some certain circumstances and conditions, you can use raft for survey. So you can fill up a ballast tank in quite a large ship or even a cargo tank. to use a raft for survey. And under 215 it says must be a planning meeting before the survey commences. And the cleaning should be, I have a picture of this here, that we have a nice light color here, so we can see if there will be a crack. It will be easy to see in this color. If it would be another color like red, it could be hard to see it, right? And black also. So there's a requirement for having light color in ballast tanks, and also in dry compartments on bulk carriers of above 150 meters length. So what you can do here, you can have a high pressure fresh water washing, much better than seawater, of course. Then it would rust and not so very good. So we want to have high pressure fresh water washing to clean this area, to blow away all these scales and rust, to make sure that it's not too little steel left here. So all spaces, as in the text, shall be cleaned, including removal from surfaces of all loose accumulated corrosion scale in tanks where soft coating has been applied. Representative areas and those areas where it's obvious that further close-up examination is required shall be cleaned free of soft coating. And well, if you know that yourself, it's good, but probably in that case, the surveyor will tell you what he wants to look at a little extra for his close-ups. But as I said, also the soft coating, this is a picture about maximum survey distance, maximum 5 meters, if it's good coating and looks okay. If you stand at a distance from a certain surface and everything looks just perfect, like the very well-maintained Dunse or Dunse ships, and you can't see an actual reason for any kind of survey. But if you have this light paint and there is a crack in the steel and also in the paint, you can see also that the rusty water. If you can't feel sure about this, you should just require to go closer, so you can make sure that it is okay. So about these components I mentioned for the classification, the class is a standard of a component we have. The hull is a component, and that is also specified how it should be, this component, the hull, the thickness of the shell plating, the strength of the girders and stuff. So we have a hull list here, as it looks like here in the DNVGL's homepage. If you have a ship with the DNVGL class, you get a login to their homepage and you can check your own ships. It looks like this. It says all in this list, Hulexa down there. That's hull examining. And there's also hull PTS. PTS stands for pressure test. So here we should just see hull examining here. You see the slop side tank and which frames this slop tank is between, frame 42 and frame 44. So in the aft then, you have quite many frames, much more than this. So this is how it looks. Your own ship, if you check into this, your own ship's homepage at the DNVGL, and you check the hull list. And we have a hull list with their components expanded to maybe 50 items, and we have the machinery list also. And we can see here the hull list is in progress. Is going through a survey right now, and the machinery list is not due yet, so it's green, and there's usually something good if it's green. You see the other items as well is outside this system with these items, the item list, like the bottom class and the shaft, the tail shaft monitoring, like that, and the boiler. So it's also could have its own dates, but they usually like to harmonize those dates. Regarding ultrasonic measurement, ultrasonic thickness measurement, UTM, there are requirements for all ships about those companies. The UTM firm shall be approved by class, and those approvals usually depends on Ajax approval. So to be in conformity with other societies, Ajax want to conform this class with each other, so they give about the same standard of the ship. So there should be a surveyor on board and plan the ultrasound thickness measurement together with the UTM's operators prior to commencement of UTM. Measurement not taken in cooperation with class will be rejected. Well, that may happen. I've seen those UTM firms working without class, so well, I don't know. And there should be a meeting prior to this UTM with the owner, with the UTM company, and the class surveyor. And then wastage exceeding allowable limits as defined in the minimum thickness list shall in general be permanently dealt with before leaving port or at first port of call. During commencement of intermediate or renewal survey, so measurement not giving reductions more than 5% below minimum thickness requirements are normally accepted until the due date of the survey. So if you start the survey the last date of the certificate and you notice this 5% below the minimum thickness, you have 1 day to fix this. It's not good. So in this maybe 3-month window to check, you should be ahead in that window, so we'll not just, you have too little time to arrange and rectify those remarks. So about the UTM, we can see requirement for all ships, rule requirements for surveyor attendance during UTM on board, and Ajax, thickness measurement of structures in areas where close-up surveys are required shall be carried out simultaneously with the close-up surveys. Okay, we have reference to Ajax here and some additional requirement from DVGL here. So first Ajax URZ17 Annex 1 blah blah something, and DVGL even more blah blah, approval programs for UTM firms. So on this DVGL homepage we can find the approved firms for making this UTM. In Norway we have these 5 firms in the whole country of Norway, and Sweden we have not one single UTM firm approved. It's incredible. That's how it is. And those teams comes in 2. There's 1 climber, a very fit person, good condition, and a little heavier person maybe, writing down what the climber reports to him, sitting under a sort of umbrella in the shade somewhere, something, with his radio. And the climbers are more expensive as well. So they give you a price ordering UTM firm. 1 climber costs $150 per day maybe, and the other one costs $100, or more like the double something for both. So it's very well specified cost for these firms, and they are hanging in a bosun's chair. You know what a bosun's chair is? There's a little plastic seat usually and hanging in a rope. So it's quite a dangerous job. They have this little sensor. They check over the whole area. So if you like I did on this Suez Max tanker, 150,000 tons, it would be like 700 pages. On each page you can find 100 of those measurements, or even more actually, maybe many hundreds, several hundreds. It's incredible. So each ship with the length of not less than 100 meters, should have a minimum thickness list, so we know who we'll be comparing with. So it's stated how thick the material is and what is the minimum requirement. A major part of this this list here and the requirement for the thickness of the steel is for the buckling strength. If you have a field pressed together, it's be like spaghetti, so it buckle out, and that reduces the strength of the hull very, very much. The spaghetti is much stronger if it's straight than if you manage to bend the spaghetti, right? It's the same thing here. So the thickness makes it bend easier. That's it. So that's a problem for the high tension steel ships, that the material is strong, but it's not that thick. And if it's thin, it would buckle easier. For ships of less than 100 meters in length, the buckling usually is not a major problem here, because we don't have the long ship bending forces here in those smaller ships. And about the minimum thickness list, so where you will request deck and bottom plating to be measured first usually. And he would suggest also and propose location of the 1 to 3 transfer sections belts. Transfer section, that is that's an area between two frames. If it's between two frames and also the connections on the other side of those frames, if it's a transversely framed ship. We are two types of building hull here. There's a long ship frames and a thwart ship frame. If it's even corrosion here, one section should be placed midship because we have the most bending moments midship. The bending moments at the max at the middle of the ship. So regarding this UTM and close-up surveys, I'm going to go into this a little. It looks completely horrible. You see these tables and a lot of stuff here, but it's actually, you can ignore most of this, right? Our ship is just one age, right? Our ship is between 10 and 50 years. So how to check the transfer sections in way of the cargo area within 1/2 times L, a midship. Now, what is that? So we have a ship that is 100 meters long, right? So what is 0.5 times L? That's 50 meters. So we just take the ship in the middle, L2, we call it, and we go 25 meters to each side, where we have this maximum bending moment. So we should have 2 complete sections and 2 different spaces. There we should check it. And if there are like a cargo hold or hatch covers, combings, of course, we should check all platings and stiffeners around. So what is substantial corrosion? We can see down in the next table 8 here. Well, that is between the minimum allowed thickness of the plate and the minimum allowed thickness plus 1/2 millimeter. So it's just about to be too little material here. Then it's substantial corrosion. Then there should be a close-up survey of this. And the transverse section here is what. So again, this is a description about how to measure these distances from the L1/2 for this ship that is in our example here, 10 to 15 years of age. So you just have to, you can just ignore the others. You don't drown in this. You just check what you have to do. You see that the main deck plating in 1A for our tanker, for instance, it is not necessary. So these codes here, 1A, 1B, is just another way to say main deck plating and the cargo hold, hatch covers and combing and stuff. So it's not so mysterious, those codes there. So about this close-up examination, we can have an example here about the single skin bulk carriers. They are very prone to accidents. This bulk carriage is not even 5 years old. You have to check everything here. Cargo hold, hatch covers and combings, plating and stiffeners. You check all if it's not even 5 years old, the ship. So this is a problem. So that's why they focus very much to check these in close-up examination, which is a close-up, not just a thickness measurement. You should check all these connections. You should check the welds. You can check all the change in structure, everything. And there could be close-up surveys by remote. You could have a climber with a little camera and a radio where we ask him to go to several locations to check the condition of the steel. And we can have divers in field ballast tanks, and we can have the remotely operated vehicles, and we can have those mentioned the rafts also possible under some condition, depending on the stiffeners dimensions actually in a deck frames. So you have to study. If you're going to use a raft, you have to know the dimensions and the conditions for it. And it's stated somewhere. It's not very much text. So regarding structures, and I mentioned these single skin bulk carriers. Here we have an example of a dry cargo ship, where the structure changes, where it's not any more continuous steel like you see in the middle of the cargo hold here. It's continuous all the way to that. Suddenly comes a bulkhead here, and at the bulkhead, the connecting steel is stiffer because the bulkhead will help to make it stronger there. Then the deformation of the steel in the smaller part, the more narrow part of the deck here will be more prone to cracking, because there's more strength and more deformation in that smaller part of the deck instead, and the bottom as well. So where the structure changes in area is usually where it's most the greatest risk for cracks. About pressure testing, you saw the Hulexa in the hull list. There's a hull PTS also, that's pressure testing. How to pressure test? I made it a drawing here. It's horribly ugly, but I can say it's corrosion, but it's actually me just trembling before this session here. But which pressure are you supposed to apply when you're making a pressure test? So we pressure up to the top of access hatches or air pipes. So if there would be higher pressure in this water here, that is more water, it will just flow outside, right? So we pressure test to the top of this gooseneck and the bottom side of it, like this. A little more here, and it will just flow over. And the external inspection of tank boundaries by surveyor and confirmation from master that pressure testing has been carried out could be accepted if they have it noted somewhere for fuel oil, lubrication oil, freshwater tanks, and cargo tanks. Regarding coating, they have some levels here, 3 levels. We have good first, only minor spot rusting. We have fair, local breakdown at edges or stiffeners, and well connections, and or light rusting over 20% or more for areas under consideration. And then we have poor, general breakdown of coating over 20% or more of areas around areas, or hard scale at 10% or more of areas of consideration here. So essential for coating conditions: humidity when applying the coating. We said that also in the maintenance course. The sacrificial anodes, there are 2 systems, there were 2.5 years and a 5-year system. If you have a 2.5-year anodes in the double hull bottom, the ballast tanks, and you have 5 years between the dry docking, is not very good idea. We have the ICCP, impressed current cathodic protection. The surface roughness is very important here, so that the paint will stick. So 75 micro is what is standard here to have a good surface for applying paint. And then if you do this correctly with low humidity and stuff, and the correct temperature at the steel even, the coating can last for a very, very long time. Oops. This is a helper area. Port side, I think it was double bottom tank 6. Horrible. So, substantial corrosion, and the rest is for removal. And probably it's a good idea to remove the substantial as well. Here, this ship should be upgraded to Cap 3 so they would get good charter. But it became very expensive to fix this, of course. The problem here was anodes for 2.5 years and 5-year dockings. Half of those anodes, they were gone, of course, they were gone. And the other half of them, they were like new, brand new, with tape all over them. So that is a reason for this very bad condition. So you make sure that the tape used to cover those anodes are gone when you leave the dockyard, and that you have the right system, 5-year system. So now you talk about this class and stuff. Are the requirements about color of paint in ballast tanks in class or SOLAS? This is a question to you, and we should think about this for a while. Do you have any suggestion? Do you think that there are any requirement about the color of the paint in ballast tanks or in class or SOLAS? I found this text here. I just went to this lovely chapter 2.1 in SOLAS regulation 3.2, protective coating. And we find in this regulation 3.2 a resolution 215 Maritime Safety Committee. So I checked that resolution. What's inside? It's about protective coating for dedicated seawater ballast tanks in all types of ships and double skin spaces of bulk carriers. Okay. So I go to this MSC 215 and the standard application here. A multi-coat system with each coat of contrasting color is recommended. Okay, so you have 2 layers here of coating, and it should be not the same color. Then you can see if you missed a spot somewhere, right? And the top coat shall be of a light color in order to facilitate in-service inspection. So, and something else, maybe anything else here you see that is interesting. A lot of, we have some links here. And the bottom link here, see footnote. Doesn't that make you curious? I was a little curious about this. So I wonder, a footnote here. They're usually good footnotes. Aren't you curious about this one? It's recommended procedures for maintenance, survey, and repair. And those are nice procedures on how to do this. It's perfect for the SMS you have. And if you look over SOLAS, you have nice little lists about how to do things. And this is a little scary. MSC 215 82 paragraph 4.2. It doesn't sound so very nice, but it is nice. If you check this, it's quite easy. This is an example about how nice these circulars are, and the resolution we see up here as well about requirements for a light color to facilitate in-service inspection. Now about alternative survey arrangement. So instead of the regular survey method, hull renewal, we could also have hull continuous. We recognize this from this machinery survey arrangement here. We have the same here. You can just you can check 20% per year. So during your 5-year period, you have checked all these items. And for the hull PMS, you should first have approved continuous, and then you have PMS for this. You can check it yourself, and you have to register very well how you find the condition and stuff. You must make this checking yourself for this ESP, as you might remember from the maintenance course we had before. And so it's could be suitable to also make this continuous and hull PMS yourself. We go now into the section 5 about miscellaneous main class surveys. That is included this for the certificates about bottom survey, propeller shaft survey, and that also includes the tail monitoring, propeller connection survey. There should be a certain percentage connection between the propeller shaft and the propeller. I think it's 70% something. How they measure that, I don't actually. I've been there when they've done it, but I can't describe it. And you have to click those little pluses here, and you find out how it is, and you just have to ignore what's not relevant. That's how easy it is. Ignore what is not relevant, and it's quite easy to follow this. You just have to get used to it, of course. Then it gets really easy. So about this condition assessment program, which is to verify the good condition for a better charter. A ship that is 50 years old, a tanker ship here. Usually the charterers, they're not so interested in chartering those ships because they don't want to ruin their reputation, like the Exxon Valdez, for instance. It's not mandatory. You don't have to do this cap class of the ship. But it is if you want to show that my ship is maybe 50 years old or 20 years old, but it is in good condition. So I still want to have a good charter. So it's a classification of condition of hull and machinery that is totally separate from the class. So if you make a class renewal, and at the same time, which is normal, you make a cap class, you will have 2 different surveyors there, and they barely say hi to each other even. It's incredible. They will walk around in the hull and check the dimensions and stuff, and so it's a different job. They hardly even communicate. It looks a little strange with the 2 persons from the same company. And they judge the ship the condition. They say that this ship has got this much steel extra above the minimum thickness all over, so we can say this 50-year-old ship is like a 5-year-old ship maybe. They judge the ship by condition, not by age, and requirements varies between oil majors. And about this program, why we have this program is that we have all these accidents. I mentioned Exxon Valdez. We had this sinking Erika, also political reflex of this, and that was to ban single hull tankers from European waters. And that was made with the CAS, the CAS class that we had before, and that is now, they don't exist anymore, unless we have certain cargoes that are not dangerous to the environment. So it was, they banned the single hull, and European Union pressurized IMO about threats of unilateral action that would forbid those tankers to arrive. And that accelerated phase out of single skin tankers and interactive with the CAS I just mentioned. And that's just relevant for single hull, and they are gone now, those ships. But the CAP class is a commercial requirement to have their tankers still interesting for charterers. So the owners, they want to show that our ships are still okay, and I hope you can let us have this very nice charter even after the birthday, the 15th birthday of this ship here. The technical standard should be very, very well documented and verified. So these two tankers here, on the right side, we see a ship that looks quite fine from here because it's painted in rust color. That's very clever. On the left ship, we can see there's even sinking, and that cannot be good. There's no excuse for that. So the difference between CAP and class will be described here. CAP is a consultancy service and is independent from the class and complementary to classification. The CAP service is rendered according to a contract with the client and rendered to ships with or without DNV class. There are also other societies, China class. They have also a CAP class on machinery, China class. As far as I know, they don't have that in DNV GL. As I said, voluntary. The class is a continuous service based on regular inspections and the issuing of class certificates with specified validity periods. A CAP declaration is issued documenting the actual condition at the time of inspection just. And it's not, if you have a 3-year-old CAP declaration, it's not as valuable as a new one, of course. But it's the same about main class, by the way. So the difference between these class. First, we have the red one. Below the red one is below CC. That is class condition. A ship that does not fulfill minimum requirements. That's a CC line. You will get the CC. There's too little steel. The stiffeners are not strong enough because they have been corroded or whatever it may be. And have the CAP class between CC and the one above is satisfactory, and very few oil companies would just be happy with that. And the highest class is very good. Is 1 is almost like new then, and the charter preference you see here is not less than 1 actually. If you want to have the good charter, it's about the market, of course. If you have very few oil tankers, they have no choice. They would give a good charter to not such a good ship. So you see the grades here of these ships. So CC line means class condition. You remember what it's called if it's a condition of authority. That is CA. Condition of authority. If it's the class has written a remark about against SOLAS or MARPOL. Better charter when fulfilling charter preference. And also there's a CAP policy. If you had a crack, if you have a crack affecting the CAP rating, there's a background here. Is the focus on cracks in ship structures? That is what is a threat to the safety of the ship from the oil majors and other stakeholders, and these must be reflected in the CAP service. So we have cracks affecting the CAP rating. They are all cracks in location defined as hotspots in the CAP fatigue analysis. Recurring cracks, if it happens, a crack suddenly appears and then reappears regardless of location, and you have a pattern of cracks. You can see at every frame you have the same kind of crack in the same well, like in the same location relative to the frame, for instance. You see that then it's a strength problem, a global strength problem with the hull. And you have critical cracks affecting the vessel's integrity of global strength, regardless of location also. So repair of cracks, the main structural element affecting the cap is, well, re-weld it. You see a crack and you put a weld. We know that is not a very good idea because the materials, the crack happened because it was a fatigue there. And the material just beside the crack is also not very good, it's very bad. So it's about to be cracked, that material. So if you re-weld it, you can have it approved, cap 3, so just above the CC line, but that's it. If you renew it, you have the same kind of design, same construction. You just replace the material, but you know there was a crack there before, so it will probably crack again sooner or later because the crack happened before because of too much tension and too many cycles for fatigue. And then we modify the design. We redesign it. We know that design did not work, so we change the design in this way. Maybe we make a radius that is distributes the forces better in the material. If you make that kind of modification, another design, it will not affect the element rating. You will still keep your cap 1 class. So for cracks in welds only, renewal of a weld by gouging and re-welding is considered a good repair. If it's just the weld that has cracked, you can just remove the material of the old weld and some centimeters around it, and you can re-weld. You can get in, if it's a weld, cap 2 for that one. We have an example. 5 cracks in a hopper tank were found in flat bars connecting to shipside longitudinals. Are the cracks considered to affect the cap rating? So then, is it identified as a hotspot in the cap fatigue analysis? The crack is in the flat bar and not in the longitudinal end connections of the longitudinal stiffeners. So, conclusion is no. Recurring, has it happened before? The location has not cracked before, so conclusion is no here. So is there a pattern of cracks? Can I find this type of cracks in more locations like this? It's occurring in more than 2 locations within the tank on the similar location in regard to a frame, for instance, or a stiffener. Then it is, conclusion is yes. Is it critical? It is considered not to affect the vessel's integrity or global strength. So the conclusion is no. So at least one of the criteria is fulfilled. The cracks are affecting the cap rating. Repair methods, re-welding, cap 3, as I said. And renewal by insert, same design, change material. Acceptable for the client and for the vetting, but cap 2 is may not be enough for a good charter. And the modification of the detail in accordance with class will give us cap 1 if structure in the tank is very good. That is not really required by clients or vetting, but I say that many times the oil majors they want to have cap 1 ships if there are too many oil tankers on the market. How to evaluate this corrosion, pitting in the steel? Well, we have in this document from DNVGL, we have these examples. How it looks if 5% is scattered corrosion here, and if it's 25%. So we can just compare how much rust it is. So you have these measures, this picture here in this paragraph 234, I said. That's at page 62. Now we have a question again. How to perform thickness measurement excluding close-ups and substantial corrosion? It is not as difficult as it may appear. Actually, our question is how to perform thickness measurement excluding close-ups and substantial corrosion. We have a double hull oil tanker, 10 to 50 years old. We check this under the DNV PDF structure with its plus signs. We expand those lists. Let's see if this works now. No, it doesn't have to. excuse me. We check under renewal, section 4. This is a component, and a lot of stuff is said by IMO in guidelines and resolutions, well, circulars. But in this case, it's further specified by class. And the Classification Society checks the hull dimensions. So in DMVGL Part 7, Chapter 1, Section 4, Paragraph 214A, thickness measurement of hull structure, including close-ups and substantial corrosion. Let's see now. I go to this one, 214. Thickness measurement of hull structures shall be carried out in accordance with 4. Just like the WINDAS, remember? So we click on the 4 here in the PDF document here. And that gives us this. Tables of close-up examination of thickness measurements. So minimum thickness measurement, all ships in table 5. And it's not a passenger ship, it's like a tanker. And the thickness measurement, substantial corrosion, is table 8. We won't care about that because now it's just about thickness measurement in general, not substantial corrosion. And the next one is here. Double hull oil tankers, the ship type specific part here. About the thickness measurement without the close-ups and the substantial corrosion, we have table 22. So this is a table with lots of information, but we have to just ignore what doesn't concern us in this part here. So we see this table here, and what we have here, we have the 0 up there, transfer section, 2 complete sections, 2 different spaces just. So we have 2 tanks within this area. You remember 0.5 times length, amidship. And the cargo hold also. Otherwise, it's nothing. But what is this specific for tankers, that is? And now we go to additional for the oil tankers is here. So it's a table 5 here. And you can just describe this in, you see, 2 sentences with the age of our ship, 10 to 15 years. That's it. And all the text here, you don't have to worry so much about. And the same thing for the next one here. 4 tankers, double hull tankers. We have this. So in 1, 2, 3, 4, 5, 6, 7, we have 9 sentences to describe what you're supposed to have measured thickness of here, the steel here. So it's not very much. You just have to ignore what's not relevant to you. And you see that in the column to the right here, that is what you're supposed to do in the locations to the left. It's not that very tough, but very few people will manage to find this, and it takes time to understand how easy it is.